Hello guys, welcome back to my channel, Memo African Motives. In this platform we shall be focusing on statics, which is actually working with moments for engineering science N2. So we've been working with these questions before, and it's just a continuation working with question papers. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Memo African Motives. Okay, so the question that we are given here is a light horizontal beam. So we are given a light horizontal beam is 15 meters long and is supported, take note here, it is supported at the left end and 3 meters from the right. Okay, then we are given this situation. So the question is make a neat sketch of the beam and clearly show all the dimensions and loads. So we need all the dimensions and the load. Okay, so let us first start with this information that we are given. So this is what we are having on 2.11. okay, so on this sketch we can actually have something like this. Just try a sketch. Okay guys, this is just a sketch. You can just draw a line. So this line is actually representing like the 15 meters that we are given, and let's see from this information. There is a light beam which is 15 meters long, and there's a support at the left end. There's a support which is at the left end. Okay, so this is your left end, so there's a support here. So remember, the support is always facing upwards like this. So this is your support here on the left end, so you can just name this L. Okay, let's see the other part. And 3 meters from the right end, and there's a one which is 3 meters from the right end. This is your right end, but in between here there's a support which is there, which is on the right end, and there's a difference of 3 meters. So you can actually indicate this by 3 meters here from the right end. This is your right end. Okay, and there's a 3 meters, so this is a support on the left and another support on the right. Okay, then let's go through the information that we are having. The beam carries the following point loads. So these are the ones which are facing downwards. 120 Newton, 2 meters from the left end. So this one is 2 meters from the left end. Okay, that is from the left end. So somewhere here is 2 meters. So we can just put something like this, and it's facing downwards, and there's a difference of 2 meters here. So you can actually put the distance in between here of 2 meters, or you can just write it on this other side. And this is a force, take note, it's a force of 120 newtons. So you're supposed to indicate 120 and 2 meters, which is in between. Okay, so this is 120 actually, that's 120 newtons. Okay, then what else do we have? 80 newtons, which is actually 5 meters from the left. Okay, so this is 5 meters from the left. So remember, we have 2 meters from the left, so 5 meters, which means we shall have somewhere here. Okay, so this is a force of what? Of 80 newtons. The one that you're having, it's a force of 80 newtons, and it's actually 5 meters, so which means in between these we are going to have 3 meters. So 5 minus 2, we are going to have 3 meters, because like the whole of this part here from this point, let me just indicate from this point here in between here, that's where we are having what? 5 meters, but this is 2, so which means we are going to remain with 3 meters here. Okay, then what else do we have? Let's say the other part, we have 90 newtons, which is at the right. This is direct at the right end. Okay, and this is your right end, and it's 90 newtons, this one at the right end like this. Okay, so this is at the right end, and this is 90 newtons. So that's the diagram for us, guys. That's the diagram on 2.11, because the question was actually asking us to make a neat line sketch of the beam and clearly show all its dimensions and loads. So these are the dimensions and the loads. So actually you can also indicate the distance between L and what? L and what? This one, because remember, it's a 15 meter. Is that so? Yes, it's a 15 meter. 15 meters, and we have covered only 3 meters, so which means we shall remain 15 minus 3, which is 12 meters. So in between L and R, there in between the supports, there is 12 meters. So you can actually indicate that it's something that is clear. Okay, then let's see on 2.12. Calculate the reactions of both points of the support by taking moments about both supports. So these moments are supposed to be taken both. Ignore the weight of the beam. Okay, so we shall take this, that is 2.12. Okay, so you have 2.12 in this case. Okay, so let's see what we are having. The first thing that we can take, we have to take either moments about L or R in this case. So let's start with L. Okay, so we have moments about L. So remember that when you're taking moments about L, you are referring to L as a reference point. That is, this is the L. So as we can see from this L, all of these forces, they're actually on the same side. So that means they are going to be taken together. So remember, we have the sum of the clockwise moments should be actually equal to the anti-clockwise. So we have clockwise moments being equal to the sum of anti-clockwise moments. So this is anti-clockwise moments. So you have clockwise moments and anti-clockwise moments. So yeah, this is just, guys, something which is direct. Okay, so you can actually put this is according to L. So according to this point L, the support L here, you're going to take the distance, the moment from R back to L. So there's a distance. Remember, the moment, it's the force times the distance. So the force of R times the distance, which is in between of what? Of 12. So it's R times 12. Okay, which is 12 R. So we have 12 multiplied by R like this, which is equal to the ones that we are going to take from each force back to what? To L. So let's start with 120. So 120 here back to L, there is a distance of what? Of 2 meters here. So it's 120 times 2. Remember, it's force times what? Distance. So it's 120 times 2. Okay, so it's equal to 120 multiplied by 2. Plus, you move on to another one back to L. So all these should be taken back to L. So it's 80 back to L, and there's a distance of 5 here. 80 and L, there's a distance of 5 meters. So it's 80 times 5. Okay, so that's 80 by 5. You move on to another one because we still have another force here, and the distance in between this is 90 back to L. And remember, there's a distance here of 12 plus 3, which is 15. So total distance here is 15. So it's 90 by 15. So it's going to be 90 by 15. All right. So guys, you just multiply this. It's going to be 12R, which is equivalent to. So someone can actually work out each and every moment. So you multiply this 120 by 2 from your calculator, you obtain 240 plus 5 by 8, which is 400. So now it's because of this thing that I have. Maybe if I can put it aside here, 90 by 15. Okay, I don't know if it is going to be clear. That's 90 by 15, which is 1,300, and I don't know if it's going because of this. Look how it is affecting. So that's why I'm not showing up this calculator, or maybe this side. Yeah, this side is fine. So you can see properly here. So it's 1,350. So 1,350 like this. Okay, so what you're going to do is to actually combine, guys. So because of the display that I'm having today, guys, I'm just going to add this. So if you add 1,350, we add to 400 and also to 240, you're going to obtain 1,990 like this. Then you divide by 12 by 12. So if you divide by 12, that means our R is going to be the answer that we already have here. Divide by 12, we are going to obtain something like 165,83333. okay, which is 165,833, which is 0.8. We can just leave it like that. And these were newtons, so it's going to be in newtons. If they were kilonewtons, you're going to write this as kilonewtons, but these are direct newtons here. So which means the support of R here, we have it is 165,83 newtons. So this is what we are having. So we have to do the same to calculate the value of L. So that means this time we have to take our moments about R now in order for us to calculate the value of what? The value of L. Okay, so remember the question is asking us to take moments about both supports. That is why we have to use another support now. So we have moments about R. If we take moments about R, still we have the same concept of clockwise and anti-clockwise, so forth. Okay, so this time I want you to see the way that I use the easier way that I just use for me. Okay, so this is your point R like this. So this is your reference point or your reference support. Okay, so what you're going to do is that this is your L. So you're going to take the moment from L to R like this. So it's force times what? Times the distance, which is L times the distance of what? Of 12. Okay, I wanted to show you something which is easier that I use. So it's 12 times L. Okay, let us come back again to our diagram here. This time is different from this part where all these forces were on the same side of the other support, which is R like this. This time, if you are to cross check, we are talking about L from the previous part. Okay, so if you are to cross check all these, they were on the same side of what? Of R like this. Okay, but this time, since you are taking your moments about R like this, I want you to see that these two forces here, yes, they are on the side of L, this one. So these ones are going to oppose L because they're on the same side of L and they're pointing downwards. L is pointing upwards. So these two are going to be on the opposite side. But this one, which is on the opposite side, since it is on the opposite side of L, it is going to work hand in hand, or it is going to work together with L. Take note, guys. This 90 is going to work hand in hand with L. So it's going to be 90 back to R here, which is 90 times 3. And you add to the one that you have. Okay, so that's 90 times 3. So plus 90 times 3. Which is equal to, since we do not have any other, we are now going to take these ones which are on the same side of what? Sorry. On the same side of L. This is your L. These two which are on the same side of L. So it's force times distance, which is 120 back to R here. So take note, there is let's see. The whole part here is 12, and we have taken what? We have taken 2 meters here. So 12 minus 2, that means you remain with 10. 12 minus 2, you have 10 meters. Okay, so from this force of 120 back to R, there's a distance of 10 meters. So it's 120 times 10. Okay, that's 120 times 10. That's how you take these ones. Plus, still we have another one of 80, because this 80 is still on the same side of what? Of L. So it's 80 times what? R, the distance back to R here. Okay, let's see what we have. We have 10 meters, but out of this we have taken 3 meters, because take note, 10 meters is from this 120 here. That is where we have 10 meters, and we have taken 3 meters from the 10 meters. So which means we are going to remain with 10 minus 3, which is 7 meters. So in between here we have 7 meters, because this was 10 from this force here to this point. That is where we have 10. 5 is something else from the other part. We are working with this 10. Okay, so don't confuse with this 5. So it's 10 minus this 3, which is going to give you a 7. So there's a distance of 7. So it's 80 times 7. So we are going to add 80 times 7 on this one. Okay, so these are the moments that we had. Okay, so as you can see, we do not have any other. It's now a matter of working now or combining these together and see what we are going to have. So this one is going to give us 12L plus 90 times 3, which is going to give you 270 from your calculator, if I'm not mistaken. This is 270, guys. Okay, 90 times 3, that's 270. So you've got 90 by 3, which is 270. Okay, then we move on. 120 times 10, which is 1200, plus 80 times 7, which is 560. Yeah, it must be 560. So this is 560, like this. So this time, take note, we have to transpose the 270 to this side. So it's going to be 12L, which is equal to, you add these two. Then since this is a plus, when transposed here is going to be subtracted. So you're going to subtract 270 like that. So it's 560 plus 1200. Then we subtract 270. In this case, we're going to obtain something like 1490. Then we divide by 12 by 12. So that you can obtain your L, you have to divide by 12 like this. Okay, so it's a decimal again. So it's 120, this is 124, as you can see, 124, 1666 and so forth. So it's going to be 124, since the first question here, we used 2 decimal places. Let's also use 2 decimal places so that it can balance well. So it's going to be 17. So it's going to be 17 newtons. So this is going to be our force, or the support L. So that's what we were asked to do in this in the case when you're asked to take moments from both supports. That is what you have to do, because yet there was no option. You are asked to take moments about both supports. So that is why we are limited. We are limited so much because of the question that we're given. Okay, anyways, we are now asked to check the answer by balancing upward and downward forces. So how do you balance upward and downward forces? You come back to this diagram. Remember, we calculated, or we obtained the value of L, which is 124,17. This is your L, 124,17 newtons. Okay, so to balance this, or to cross check, you're going to just add the upward forces. These ones, these 2 supports which are facing upwards, should be equal to the sum of the downward forces, the ones which are facing downwards, like that. Okay, so that's how you cross check this question. So it's going to be that's 2.13. Yeah, just that's 2.13. So you're going to use this concept: the sum of the upward forces is equal to the sum of the downward forces. This is in your formula sheet. So F up and F down, sum. So F up, which means these ones which are going upwards, is L, and R in this case, these 2. So it's 124,17. That's 124,17 plus summation, means you are adding sum of, plus 165,83, 165,83, like that. Okay, so it's going to be equivalent to the sum of the downward. So this is sum, guys. Summation means sum, okay, from your mathematics. So these are the ones which are facing downwards, the other forces, these ones. So we're going to add 120, 80 and 90. So we have 120 plus 80 plus 90, like this. Okay, so just try to combine properly, guys. You're going to obtain something like 290 here. Also on this side, you're going to obtain 290 if you add this properly using your calculator. So by just having these 2 equal, it means this is true, because the sum of the upward force should be equal to the sum of what? Of the downward force. Okay, that's what we had. And on 2.2, we're given a force of 250 Newton X at 40 degrees to the horizontal, calculate the vertical component of the 220 Newton force. What are they asking here? What are they actually asking? Okay, we know that when there is an angle like this, it's actually an incline that, sorry for that, it's actually an incline that you are working with. So there's an incline which acts with an angle of what? Of 40 degrees, something like that. So this is actually something like this, 40 degrees, and we are actually given a force here which is 250 newtons, something like that. Okay, so we know that when you are given something like this, and we are asked to calculate the vertical component. This is the vertical component here. This one, that's your vertical component. So you have the vertical component, and you also have the horizontal component. Okay, so this is VC, or you can just write as Y because it's according to the Y-axis. So someone can write it as VY or can as VC. Okay, and this is your horizontal component, which can be HX or HC for the horizontal component. Okay, so always the vertical components is the force that you're given, sine theta. Okay, that's your vertical component. So it's F sine theta. If it is horizontal, it's going to be F cos theta. So the reason why I'm having this is because it's a revision. We are doing revision, guys, so there's no need for us to rush. Let us understand the concept, because the question might not ask you the vertical, it must ask you the horizontal, so you need to know this. Okay, so that's the vertical component for you. So which means the vertical component is going to be the force, which is 250 cos sine, sorry, this is sine 40 degrees. Take note, sometimes they might give you mass. If you are given mass which is in kgs, then you have to calculate the force, which is actually the weight. You calculate as the weight, which is using mg. Okay, but here we are already given in newtons, so there's no need for you to use the mg part. You're just going to use this. Okay, so using your calculator properly, you must obtain something like 160.7 newton if you round off to one decimal place like that. So that's how they actually ask these questions, guys, on statics, working with moments and forces. So as you can see, it was a pretty nice question. It was a pretty nice question, a question that stretches us further, where you need to know how to sketch the given diagram from the information that you are given. So it's actually a nice question. This one is actually a nice question. It stretches you further, not to depend on a question which is direct, but also on a question which is something like this. So guys, that's it from Mezon African Motives, working on question papers and revisions. Till we meet again.